C2, differentiation, example 6. So here, Farmer Giles wants to make a pen for his sheep. He has 1,200 metres of fencing and he's wanting to get the maximum area that he can out of a rectangular pen. So again, we need to start off by drawing a diagram. So it's a rectangle again, and we still have sides length x and y. So the area can be found by doing x times y. So that's what we're trying to maximise, x, y. But of course, this time we know that the perimeter which is equal to 2x plus 2y is equal to 1,200. So I can divide that whole thing through by 2 to give me x plus y equals 600. And then I can make y the subject of the equation. So that'd be y equals 600 minus x. So that then I can substitute that into the equation for the area so that then I can differentiate it. So I'm going to substitute in y equals 600 minus x into the area. So that would give us area equal to x, lots of 600 minus x. And then I can expand that. So a would be equal to 600x minus x squared. So we're trying to find the stationary point which would give us the maximum area. So stationary points can be found at, in this case, dA, because we're differentiating the area, with respect to x, so dA by dx equal to 0. So now we need to find dA by dx. So dA by dx, so multiply by the power and reduce the power by 1 would give us 600 minus 2x. And we need to find where this is equal to 0. So 600 minus 2x equals 0. I'm going to take the minus 2x over to the other side, which would give us 600 equals 2x. And then divide through by 2 would give me x equals 300. So I have an x value now, but I do not know if this is maximum or a minimum point. So I need to do d2a by dx squared to determine the nature of this stationary point. So d2a by dx squared. So differentiating this again, so the 600 would disappear and we'd just be left with minus 2, which is of course less than 0. So therefore we have found a maximum point at x equals 300. So we know what x is equal to. We now need to go back and use this to see what y is equal to. So y equals 600 minus x, so that'd be 600 minus 300, which would give us a y of 300. So if we have 1,200 meters of fence, the largest area is found by having a square field, or a pen in this case, with length 300 and 300. So in this case we've got meters. So the maximum area is a 300 times 300 meter square. So again now we've just gone through the steps on the previous page to see that a real life application of differentiation can find us, in this case, a maximum area using parameters which we are given. So we end up with a 300 by 300 meter square.